All right, guys, so we're going to do some practice. And in the future, because we're going to do a lot of videos like this, when we are practicing, what you should do is write down the problem when I write down something that you need to do, and then pause the video, see if you can do it, and then press play and see if your solution was the same as my solution. Because this isn't new anymore. You did see a notes video, and this is going to be a lot of good examples. You're going to have other work based on this today to do. But what you should be doing right now is testing yourself to see if you can do the work before I do it. So based on this table of values, we've got blonde-haired people, blue-eyed people, red hair, green eyes, black, brown eyes, whatever. We got all this information about people in some sort of high school poll. And we want to know a whole bunch of different things. So let's say, for example, I wanted to know what the probability is of a person having green eyes given that they have red hair. Maybe I think that that's a rare thing. I don't think that it's likely that somebody with red hair is also going to have green eyes. So given that you're picking from only the people who have red hair, right? So this goes into our little formula that we came up with. What's the probability that somebody has red hair? That's the denominator. That's the number of possible outcomes. And the number of desired outcomes is the probability that someone has green hair or green eyes and has red hair. So if I want to know the probability that someone has green eyes given that they have red hair, since it's given that they have red hair, I'm only picking from the red-haired people, and of those red-haired people, how many of them also have green eyes? And so this formula is just the formula we're going to keep using over and over. But in this case, based on my table here, it looks like the number of people who have red hair total are 0.2, so that's my denominator, and the number of people who have red hair and green eyes is 0.15. So if I turn that into a reduced fraction, that's 3/4 or 75%, which is pretty likely. So that might go against the theory that I had. Maybe I thought that green-eyed people with red hair is unlikely, but right now it seems like if we're only picking from red-haired people, green eyes are pretty likely. Let's calculate a couple more, and I'll write these down, and then you can write them down and try to do them, and then watch the video to see if you've done them correctly. All right, so you should write these down, and then you should try to calculate them on your own, but I'm just going to quick cover what these mean. Okay, so this is the probability of black hair given brown eyes, and I can just kind of fill in maybe. Black hair is BK, brown eyes is BN, and then we've got the probability of blonde given brown eyes. So blonde is BD, red is obviously R. Here we've got the probability of blue eyes given red hair. So blue is BE, and then green would obviously be G. Okay, so this is the probability of red hair given brown eyes. This is the probability of brown eyes given blonde hair. So go ahead and try to calculate these, and then I'll quickly walk through the solutions here. Okay, so hopefully you've already tried it. Now you're unpausing the video, and we can calculate each of these probabilities. So I'll write the formula for the first couple, and then I'll just start doing them quickly. But here, if I'm trying to calculate the probability that someone has black hair given that they have brown eyes, then my denominator is the probability of brown eyes. That's the thing I'm going to start with in my denominator. And the numerator is going to be the probability that somebody has black hair and brown eyes out of all the people who have brown eyes. So first of all, how many people have brown eyes total? Well, the total number of people with brown eyes is 0.35. And of those brown-eyed people, how many of them also have black hair? Well, that's just these people, 0.25. So of all the people who have brown eyes, the people who also have black hair in that group are 0.25 of the 0.35. And so if I reduce that fraction, that's 5/7. All right, let's do another one with the formula. To calculate the probability that someone has blonde hair given that they have brown eyes, my denominator is going to be the probability of people who have brown eyes. And of those people who have brown eyes, how many of them have blonde hair and brown eyes? Okay, so we start with our denominator, which is just the brown-eyed people. And let me erase my work from the last example. But we're still sticking with that 0.35 as our denominator because 0.35 of this group has brown eyes. And of those brown-eyed people, how many of them are also blonde? 0.1. So we've got 0.1 out of 0.35, which reduces to 2/7 as a fraction. All right, so we'll go through a couple more here very quickly now. Same formula I would use. In this case, I would need the probability of someone having red hair to be my denominator, and the probability that someone has red hair is 0.2, and of those 0.2 people, how many of them also have blue eyes? 0.05 of them, which leaves us with 1/4. Next example, my denominator is going to be the probability that someone has brown eyes, and the probability that someone has brown eyes is still 0.35. We've used that one a couple times. But of those 0.35 brown-eyed people, how many of them also have red hair? 0. So if you take a look, of the brown-eyed people, none of them have red hair. So that means that that probability is 0. It's very unlikely. It doesn't ever happen in this sample. And then we've got the probability that somebody has brown eyes given that they have blonde hair. So our denominator is going to be the probability that someone has blonde hair, which is 0.35 as well. Right, that's here, blonde hair. And then of the blonde-haired people, how many of them also have brown eyes? So of this group, we have 0.1 brown-eyed people. So again, that's 0.1 out of 0.35. It's just as likely that you have brown eyes given that you have blonde hair as it is that you have blonde hair given that you have brown eyes. So hopefully you did well at all those practice problems there. I'm going to put another group of them up here, and then I'm just going to post the solutions because I don't want these videos to get too long. But in this second set of practice, we've got a bunch of shapes in a box. And so these are the different types of shapes. We've got spheres, cubes, and tetrahedrons. Those are the shapes. But all those shapes could be different colors, so they could be red, blue, or green, and they're all in a box. And the total number of shapes in this box is 60, but you've got some green shapes and some tetrahedrons, and some of those tetrahedrons are also green. So that's what this table is showing us about the information. And so these are the things that I want you to calculate. And this time the abbreviations will speak for themselves. What's the probability of picking a red shape given that it is a tetrahedron? What's the probability of picking a cube given that that shape is blue? What's the probability of picking a sphere given that that shape is green? What's the probability, this is where we're going to get a little more challenging here, of picking a shape that is either red or blue given that that shape is a tetrahedron? What's the probability of picking a shape that is either a cube or a sphere given that that shape is blue? And what is the probability of picking a shape that is green given that that shape is a cube or a tetrahedron? So I'm just going to quickly post the solutions to these, then I'll explain a couple of these, and that'll be it. So go ahead and pause the video now, try to do the first three, and then you'll see the solution here in a second. Okay, so hopefully you've paused, and now I'm going to post the solutions. Okay, so hopefully you've checked those, and those look good. Now let's talk about a couple of these bottom ones. So here I'm asking for the probability of choosing a red or a blue shape given that that shape is a tetrahedron. So let's stick with our conditional probability formula here, and our denominator is just going to be the number of tetrahedrons. So how many tetrahedrons are there? There are 21. Now our numerator is going to be all of the shapes that are red or blue and are tetrahedrons. This is the same formula that we've been using. So let's find all of the shapes out of these 21 tetrahedrons. How many of them are either red or blue? 14. I add them and I subtract the intersection, but remember there is no intersection of these two things. You can't be both red and blue. So in this case I just get to add those two things together. So that's 14 out of 21. We'll do this again. Over here, it's given that the shape is blue, so our denominator is going to be 23 because that's how many blue shapes there are. And my numerator is the intersection of cubes or spheres and blue. So how many blue shapes do I have of these 23 that are either cubes or spheres? 10. So 10 out of 23. And the last one, what's the probability of picking a green shape given that it is a cube or a tetrahedron? So now our denominator is not as straightforward, but we need to figure out how many cubes or tetrahedrons there are because that's the denominator. So there are 20 cubes and there are 21 tetrahedrons. So that would mean that there are 41 cubes or tetrahedrons. And of those 41 cubes or tetrahedrons, how many of them are also green? So 10 cubes are green and 7 tetrahedrons are green. So that would mean that there are 17 cubes or tetrahedrons that are also green. Okay, gets a little tricky, and then your homework tonight is going to be on Delta Math. You're not going to see anything like these on Delta Math, but hopefully these weren't as challenging once you saw the solution as you thought they would be, and hopefully you tried them on your own before watching the solution. So be sure to do the Delta Math assignment to see if you're able to do all this stuff on your own, and we will pick back up where we left off on Monday.